Hello, my name is Matt Milne and I'm a Senior Application Engineer within the Mechanical Analysis Division of Mentor Graphics. And today I'm going to talk to you about front-loading CFD with FLOEFD and show you why our solution is smarter and faster. First, let's talk about the challenge. Engineers today may be required to work across a range of different engineering disciplines. Alongside this new engineering approach has come a new type of engineer, and a new breed of CAE-centric design tools is needed to allow the modern engineer to work most efficiently. One way to address this is through the use of front-loading. Front-loading means the use of simulation directly inside the 3D CAD environment. This allows the design and the analysis to remain in perfect synchronization. Front-loading enables the rapid assessment of design changes by the designer himself, minimizing expensive late design changes. So what sort of features does a front-loading solution have? First, it's fully CAD embedded. This means the engineer is working inside their familiar 3D CAD environment. You don't have to learn a new piece of software, so it's a much shorter learning curve. We can use the native CAD model, so we have no exporting or translation issues. Again, because we're inside the 3D CAD system, we have full access to the parametric CAD definition. And most importantly, no geometry simplification is required. It's intuitive. The engineer is working inside their familiar 3D CAD environment. They don't have to learn new software, so it's a less stressful user experience. And I can tell you, from nearly 20 years of using simulation and CAD tools, anything that makes your day just a little bit less stressful is going to be a fantastic thing. It's highly automated. In today's world of engineering, we are under increasing time pressure with design cycles being reduced further and further. So our front-loading solution needs to be highly automated to reduce setup time. It also needs to be robust because of time pressures, we can't afford to have simulation failures. It also needs to have integrated post-processing. Now, the simulation software is not going to do the engineering for us. We still need educated, intelligent, smart engineers, but for them to do their job, they need information. So with integrated post-processing, the engineers can quickly analyze results, communicate these with their colleagues, and make an informed engineering design decision. Front-loading enables simulations to be performed early on at the front of the design process. This helps to eliminate design problems at the root cause on the 3D CAD model. Now, in the past, we've tended to do simulation relatively late in the design process, close to the test phase. What we're trying to do with front-loading is push simulation much earlier in the process so we can do it directly inside the 3D CAD model during the initial design phase and spot problems early on. If we look at front-loading from an economic perspective, it's really very simple. If we have to make late design changes, if we have to remake our tooling, if we have to remake our jigs, it will be expensive. On the other hand, if we can spot problems sooner and fix them at the start of the design process, then it's going to be much cheaper to fix, perhaps even free. Now, this is a quote from a customer of mine. He genuinely said this to me. He said, "Simulation allows us to influence preliminary design. We can be more innovative early on and drive risk out of the project." Let's talk next about FLOEFD. This is the front-loading CFD solution from Mentor Graphics. FLOEFD is CAD integrated. This means we have no problems with CAD translation and a short learning curve because you're working inside your familiar 3D CAD environment. FLOEFD combines a number of innovative technologies, and I'm going to come on to talk about these shortly. The result of this is that FLOEFD is accurate and fast, and no geometry simplification is needed. It's also very easy to use by non-CFD experts. So these are engineers who understand the physics of their problem but don't necessarily have prior CFD experience. FLOEFD is embedded inside the major 3D CAD systems. CATIA V5, PTC Creo, Siemens NX, and Siemens Solid Edge. Now I'm going to use CATIA V5 as an example here because it has the most distinctive user interface. But if you're a CATIA user, if you look at that picture, you can see, yes, you're working directly inside the familiar CATIA V5 environment. You don't have to learn a new piece of software. Exactly the same is true for Creo, for NX, and Solid Edge. It's important to remember that FlowEFD is a completely general purpose CFD tool, so it can be used across all design applications, and FlowEFD is in use today around the world by a wide range of manufacturers and tier 1 suppliers across a wide range of different industry applications. Let's talk next about intelligent CFD. What is it that makes FlowEFD different? What is it that sets it apart from other traditional CFD tools? FlowEFD employs certain technologies. These technologies have benefits. Those benefits have an outcome. The outcome is that FlowEFD is faster and easier to use and without leaving your native CAD environment. Okay, this is the scariest slide in my presentation. These are the Navier-Stokes equations. They're the governing equations of fluid mechanics. Now, to use FlowEFD, it's not essential to understand the mathematics behind these equations. Briefly, they're a statement of three very simple fundamental physical principles: conservation of mass, conservation of momentum, and conservation of energy. The point here is that this is how all CFD works. All CFD works by solving the Navier-Stokes equations. So in this respect, FlowEFD is very similar to other traditional CFD tools. This is the second scariest slide in my presentation, and the last one with horrible equations. To solve the flow field, we also need to solve turbulence, and for this we need a turbulence model. There are many different kinds of turbulence model. FlowEFD uses one in particular. It uses a form of the K epsilon turbulence model. Now this is one of the most commonly used turbulence models in CFD. So again, in this respect, FlowEFD is very similar to other traditional CFD tools. Now what is it that sets FlowEFD apart? How is it different? Well, FlowEFD was actually born in the Soviet Union in the early 1980s during the Cold War. Now the problem at the time is the Soviet Union was embargoed. They couldn't trade with the West and didn't have access to powerful Western computers. Now I'm very fortunate today that I work with a number of really smart Russian scientists and engineers, and they are fantastic thinkers, and that's exactly what they did during the early 1980s. They asked themselves, how can we have fast and accurate CFD without powerful Western computers? So they did some thinking, and what they came up with is what we now know today as FlowEFD. So this is not new technology. This is mature, robust technology that has been developed for over 35 years. The first thing that FlowEFD does that's very different is it uses a combination of numerical, analytical, and empirical methods. So FlowEFD, because it's CAD embedded, can use information from the CAD model to automatically detect regions where the mesh resolution is insufficient for a traditional numerical CFD solution. And in these regions, FlowEFD will automatically switch to analytical or empirical methods. The benefit of this is that fewer cells are required without compromising the solution accuracy. Another thing that FlowEFD does that's very, very different is it uses what we call SmartCell technology. Now the image you can see here is a cut through a finned heatsink. Now if we look closely inside one of the mesh cells, we can see within one cell we can have multiple control volumes, multiple regions of fluid, solid, fluid, solid, fluid. With traditional CFD, this just would not be possible. Traditional CFD would have to divide this cell up into many smaller cells to resolve those different fluid and solid regions. With FlowEFD, we don't need to do that. We can use a very coarse mesh and still get a fast and accurate solution. So the benefit of SmartCells is that fewer cells are required which gives us shorter run times and reduced computing power requirements. It also means there's less manual user input, so the setup time is significantly reduced. Another advantage of SmartCells is that we have no problem to resolve irregular shapes. So if we take a detailed look at some of the parts you might find inside an automotive headlight, we see we have these very small faceted shapes, perhaps only a few millimeters across. With traditional CFD, we'd either have to use many cells to resolve these, or we'd have to simplify the geometry. But with FLOEFD, we have no problem to resolve these shapes. So no geometry simplification is required. Another thing that's very different about FLOEFD is it uses an integral boundary layer model. So the boundary layer is what happens where the fluid interacts with the wall. This is a whole area of research in itself. Very complex physics. FLOEFD uses a unique model. We won't go into the details today, but the benefit of this boundary layer model is that we can get accurate results with fewer mesh cells. It also means we can easily capture arbitrary complex geometry, and it also eliminates the need for lots of different turbulence models. It makes it easier to use, particularly for new users, and it also makes it easier to automate the software. So, to sum up, what is it that makes FLOEFD different? FLOEFD uses several different technologies, so the combined numerical, analytical, empirical approach. It uses SmartCell meshing technology, and it uses a mesh-independent boundary layer model. The benefits of these technologies are that fewer mesh cells are required without compromising solution accuracy. It also means the time to go from CAD to results is significantly reduced by as much as 75%. It also means less computing power is required. Typically with FLOEFD, you can use the hardware you probably already have. Typically, it can be run on a high-spec CAD workstation. There is no need to go out and buy additional high-performance computing power. So the outcome is that FLOEFD is faster and easier to use, and it's all done without leaving your native 3D CAD environment. So, in summary, we've said engineers today may be required to work across a range of different engineering disciplines. A new breed of CAE-centric design tools is needed to allow the modern engineer to work most efficiently. This approach is known as front-loading. Front-loading, let's remind ourselves one more time, enables the rapid assessment of design changes by the designer himself, minimizing expensive late design changes. FLOEFD then is the front-loading CFD solution, smarter and faster. Thank you.